Hi class, and welcome to section 9.3 where we talk about reflections. Remember, reflections are the mirror in which shapes are reflected across. Some key concepts to remember include if coordinate AB is reflected in the x-axis, the image would be A negative B. And if coordinate AB is reflected in the y-axis, the image of the point will be negative AB. And if coordinate AB is reflected on the line y equals x, its image of the point will be BA. And if coordinate BA is reflected on the line y equals negative x, the image is the point negative B, negative A. Now class, we'll be doing number 5, where the question is asking you to graph the reflection of the polygon in the given line. 0, 1, 2, y equals 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5. One, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Remember class, this is the line of reflection where you reflect the points off of. Next, we'll be writing the coordinates. Point A will be on 3, 5. Point B is on 0, 4. Point C is on negative 2, 1. And point D is on negative 5, 2. For point A, we know it's 1, 2, 3 points away from the line of reflection. So we go back to the line of reflection and go 3 points down, where you get 3, negative 1. From line Y to point A is 3 spaces away, and in order to get the reflection, you would have to go 3 spaces down, which you would get to coordinate point negative 3, negative 1. As for point B, it is 2 units away from line Y equals 2. So you would go back to Y equals 2 and go 2 units down, getting at the origin 0, 0. As for C, it is 1 unit away from line Y equals 2. So now you would go 1 unit upward from that line, getting you C. As you can see, this is the reflection of the polygon ABCD over line Y equals 2. Next, we'll be doing number 7, where the question is asking you to find the reflection over the y-axis. In comparison to the previous question, right here is the line of reflection. So coordinate A is on 1, 4. Coordinate B is on 2, 2. Coordinate C is on negative 3, 1. Now we're going to find the reflections of these coordinates. Since we're reflecting over the y-axis, we know that only the x-coordinates are changing and the y-coordinates are remaining the same. We would find the reflection for C by finding the spaces, which is 1, 2, 3. Now we know that there's 3 spaces between the y-axis and the c-coordinate plot. Now we go to the other side of the y-axis and do the same thing, 1, 2, 3. For the b coordinate plot, we see that it's 2 spaces away from the y-axis. So we would do the same thing on the other side of the axis, 1, 2. So now we know the point of b would be negative 2, 2. For a, we see that it's 1 space away from the y-axis. So we do the same thing on the other side, getting us negative 1, 4. And this is how you find the reflection for the shape ABC.
Hello class, today we're going to be working on section 9.4. 9.4 is about rotations. A rotation is a transformation in which a figure is turned about a fixed point. The fixed point name is called the center of rotation. Let's learn about coordinate rules for rotation about the origin. So, for a rotation of 90 degrees, we will get our coordinates A, B, and then we will transform them into negative B, A. For 180 degrees, we will get A, B, they would become negative A, negative B. For 270 degrees, we would get A, B, transform into B, negative A. So let's work on question 12. Question 12 is asking, find the rotation of 90 degrees for these 3 points which form a triangle. So to find it, we would do the coordinate rules for 90 degrees, which is A and B would become negative B, comma A. So we would get negative 3, comma 2, then we would put negative 2, comma negative 3. So we got the B, and then we made a negative, and then we put the A there. We will do the same for here. We will put negative 4, comma 2. And then for here, we will get negative 1, comma 3. So now, let's move on to question 13. Question 13 is asking for a 100-degree rotation about the origin for polygon JKML. So to do this, it would be very easy. We will get each point and make them negative, because that's what the coordinate rules state for about the origin of 180-degree rotation. So for this one, we will get 1 would be negative and 4 would be negative. So you got that? And then we get negative 5, negative 5. Then we get negative 2, negative 2. And then we would get negative 7, negative 2. So that's how you get the new image for polygon JKML for a 180-degree rotation about the origin. So before we start, we should talk about theorem 9.3, which is the isometry theorem. This theorem states that any figure rotated will be an isometry of itself. This basically means that any figure rotated will be congruent to itself. This triangle would be the same as this triangle. They have the same angle, same side length, same everything. It's just that it's a rotation of itself.
Now, let's focus on section 9.5, which is transformations involving translations plus reflections. Now, earlier on, you learned of a type of transformation known as a rotation, in which you take a particular shape and then rotate it about the origin. Remember, the center rotation was the origin in these examples. Did you go like that? Now, rotation is one thing. There's all like degree measurement, etc. Another way to emulate a rotation is by using translations and reflections together. These, when combined, they form something called a glide reflection. This is done when a reflection is performed after translation. When two or more transformations are used, they're called composition of transformations. Transformation. When two or more transformations are used. When two or more transformations are used. Now, Theorem 9.5 states that a reflection across parallel lines is the same as a translation. Now let's have an example of that. Let's say you have this triangle pointing to the side and being reflected across this line. You reflect it and the resulting image is this. I can't draw it perfectly, but you get the idea. Now you say you have another line, this one. These two lines are parallel. You reflect this shape across this line, you end up with this as your result. Notice how the first shape and the final shape are the same and they're congruent and they're facing the exact same direction. According to Theorem 9.5, since we reflected them across two parallel lines, this is essentially a translation. Basically. Stop it. Theorem 9.6. It states that reflecting a shape across intersecting lines equals rotating the shape around point of intersection. So, let me show you what that looks like. Let's draw two lines intersecting. This looks kind of like our typical x-axis and y-axis. Let's start with a triangle in this area right here. First, we reflect it across this vertical line. The resulting image, another triangle. Now let's reflect it across this line right here, and we get an upside down triangle, as is with reflection. Let's draw the same thing here over again. Start off with a triangle, and then we rotate it around to this part of the graph. Rotate around, you get the same resulting image as if you were reflecting across two lines. Therefore, Theorem 9.6 thus holds to be true, that reflecting across two intersecting lines is the same as rotating around the point of intersection. In this case, probably like the origin or something. This works whether or not the intersecting lines are perpendicular or not. You'll still get the same results. Let's work with some problems now. Question number 3 of this section asks us to perform a translation and then a reflection of points C and D. Let's go with those points one by one. Starting off with point C. Number 3 of this section asks us to perform a translation followed by a reflection of points C and D. The original coordinates of the pre-image for a point C are 2 and -5. Look at the translation. It asks us to leave x as the same, but subtract one from the y value. And here the y value is -5. We know that x remains the same. Y minus 1 basically equates to -5 minus 1, which gets you -6. As for D, we have 4 and 0. 0 minus 1, x remains the same, gets you -1. Now we have a reflection across y-axis. Remember, we have 4, -1 here, and then, my bad. We have 2, -6 here, and then 4, -1 down here. Reflection across y-axis, we know that makes the x value negative. So we take the x value of 2, make that negative, and then take the x value of 4, make that negative. So you get point C of -2, -6, and point D of -4, -1. Now, question number 7 asks us to perform a translation followed by a reflection to these 3 points. Translation has the x value remaining the same, but a y subtract -5. So for P, x value remains the same. Q, same thing. R, same thing. Now we have 4 is the y value, -5 gets you -1. 0 minus 5 is -5. 2 minus 5 is -3. These are your values. Now let's rewrite them down here. Okay, damn it. Now we reflect across the y-axis. we know that reflection across the y-axis turns the x values negative. So just get the x value, put a negative sign in front of it, and you are golden. Got it.